Hey everyone, thanks for tuning in to my talk. My name is Judith van Stegeren. Together with Mariet Theune, I wrote a paper about 3 new datasets with video game text that I collected. And the focus of this talk will be the textual modality of narrative. So we're just looking at the plain text strings. If I had to summarize my talk in one slide, this would be it. So this gives a bit of context to the research that I did. And I don't just want to talk about the 3 datasets that I collected, but I also want to discuss the problem itself. Why is it so complicated for researchers to create new video game text corpora? And what are the possible approaches that you could take if you want to create a new dataset? I am a PhD student at the University of Twente, and the main focus of my research is language generation for video games. And there are a lot of different types of text that we can encounter in video games, but the ones that I'm most interested in are in-game dialogue, the game narratives, and the flavor text for RPG games. So flavor text is decorative text that is not necessary for the actual gameplay or for completing the game, but decorative text that gives a bit more body to the game world. So, and when I started out, I was very curious to learn what other data sets are being used by researchers in the field. Personally, I read the most papers from the procedural content generation field and the natural language processing field. And I found that most researchers tend to work, even if they list video games as their intended application domain, most of them work from corpora that are that have the same type of text in there. So for story generation, they work with stories, and dialogue generation work with dialogue corpora. But the texts in these corpora tend to be sourced from other domains than video games. There's one exception, Skyrim. So there's a lot of papers being published that use data from Skyrim, and I think that is because Skyrim comes with its own modding software, and it's relatively beginner-friendly. So we should probably stimulate game developers to publish official modding software, because that really helps researchers. Anyway, I also started reading a bit about how game writers work in industry, because I think that might be useful inspiration for creating my own text generators. And I started writing this great book by Chris Bateman and a lot of other people. And in the book, the authors argue that game writing is fundamentally different from other types of writing for a lot of different reasons. And it's also really different from just writing fiction. For starters, there is, of course, the interactive aspect of games to take into account. But it's also because of the game development process. So game writers have to be able to work with the somewhat erratic game development process, as games can change stories or genres or style in the time span of a few months. And game writers have to be flexible enough to be able to deal with that. And learning all this made me realize that if I'm going to analyze and generate new video game texts, I really want to work with source data that is also from that domain, from the video games domain. But as I learned in my reading, there weren't that many data sets available with video game text. So I had to roll my own. However, that turned out to be quite challenging. Because preferably, I think the most high quality data can be found directly in game files. But to extract those strings from an installed game is not really trivial, because the strings might be spread over a lot of different files. The game engine, when you play, the game engine reassembles those into the stuff that you see on screen. But extracting that data is not really easy to do, even for researchers with a degree in computer science, because you have to understand how the game works at a very low level to be able to access that data. So I started talking to a game developer buddy of mine, and he gave me a few ideas. And of course, I also read how people solve this problem in the scientific papers. And eventually I found these three possible approaches that I wanted to investigate further. So the first option that you have is relatively easy. They're ordered from easy to complex, by the way. The first option is to build a web scraper and just go on the internet, look for fan-made websites, and start scraping the hopefully in-game texts from those. There are a lot of places on the internet where you can find transcriptions of, for example, quest texts or dialogue or cutscenes or stuff like that. So that's a great source of material. The second option, using official modding software, is only a possibility if there is official modding software, of course. Not every game comes with its own software, unfortunately, but the ones that do are generally very friendly. They're user-friendly, they're documented. Since the publisher has, released them, the publisher often has a stake in the success of the software, which means that it's probably great to use. And the final option that you have is going on the internet, for example, to the website Nexus Mods, and find fan-made tooling for modification or extracting game assets. That might also be an option. So I tried all these out in practice. So the three approaches led to 3 datasets. But all of them have their own pros and cons. So depending on what you need and how technically proficient you are, you can choose, and of course whether the publisher has released anything, you can choose one of these methods. Fan wikis are the most easy to use. But if you use data from those websites, I guess it's similar to using the data script from Wikipedia and everything. It's crowdsourced data, so you might have to do some extra cleaning, you might have typos, you might have incomplete data. Not all websites contain the same data, so what you can find for different games is you're completely at the mercy of the fan community. So that's the pros and cons of number 1. None of these methods really scale, by the way. That's too bad. So you can build one extraction tool for one game, but the chance that you can take it and apply it to another game is basically 0. With an exception for games by the same publisher. The second method I really like, but there's only a minority of games that come with publisher sanctioned modding software. And the third option is for adventurers only, because it means you have to install a lot of undocumented or very old tools and see if there's anything that does what you need it to do. But it's what I used for the final data set, and it led to some very nice, high-quality data. So, one data set per approach. From a fan wiki, I scraped all of the in-game books from the RPGs in the Elder Scrolls series. I used the official Torchlight II modding software called Guts to extract all the strings from that game, and I used a collection of open source fan-made tools to extract all the branching dialogue from Star Wars Knights of the Old Republic 1. So, in-game books from the Elder Scrolls, what does that mean? The Elder Scrolls is a series of action RPGs, and the developers use in-game books to convey more information about the in-game world to the user. So the player character can walk around the world and encounter books in shops, in houses, and the cool thing is that every book can be read. And the advantage of this data set is that the books contain relatively large texts. Most of the text in games are really short to save the player some time. But this data set is actually pretty big, and in a previous work of mine I used it to learn the semantics of non-English words from this data set and then create a sentiment analyzer based on those semantics. And I think it can be very useful for many different kinds of NLP applications that focus on video games. It's a very good starting data set because it's so large. The second type, or the second data set, is really different from the first one in that it contains many different types of text. So the previous one contained only flavor text and only book text, fictional book text. Whereas this data set is much smaller, but it contains a bigger variety of texts. I think it fits very well with Kristen Yu's talk from yesterday about quests, because it contains the starting, intermediate, and completion dialogue for every quest in Torchlight II. And apart from that, it also contains all the GUI text, so the things like one-line quest objectives and toolbox tips and stuff like that. And it contains long-form summaries of the main quest. So it actually contains the entire main quest narrative of the game as well. And this variety is something that I really like about the second data set. And the third data set contains branching dialogue, something that Star Wars Knights of the Old Republic 1 is really famous for. It's a relatively old game, I believe early 2000s, from publisher BioWare. And BioWare is famous for its high quality writing and voice acting as well. So let me show you a very quick clip on YouTube.
Hey, I ain't no kid. I look out for Zalbar as much as he looks out for me. Bixie's my friend, not my babysitter. Geez, I come ask you a question, you give me a lecture.
Don't you snap at me, Missy. You want a lecture? How's this? Only bratty little children fly off the handle because of a simple comment.
So this is an example of a dialogue in the game. There are two NPCs fighting in this little clip. They've just met and they don't really like each other. And now there's a pause screen, and the player character, which you see on screen right now, can choose how they will react to the NPCs. So this player will take, I believe, the second option.
Oh. Totally instigate.
I don't have to listen to you, Karth. You ain't my father, though you're sure old enough to be.
So via this branching dialogue, the player can have a lot of influence on how their character reacts to situations and dialogue lines by other characters in the game. Not every choice is really meaningful, so sometimes it doesn't really matter which option you choose, but in some cases you can really steer the story in a particular direction. In the Star Wars games there's of course a big focus on the whole good versus evil, Jedi versus Sith alignment, and this is how they, partially how they implement that. And branching dialogue is not something that you find in every RPG. But I'm really happy that I collected this data set because it contains over 30,000 lines of dialogue, including information about the conversation and the speakers, and it has all the branching options as well. So this data set can be used to research how branching dialogue in games works, what it looks like, and hopefully also to generate new branching dialogue. So I hope this helps researchers out there that are interested in that particular topic. So again, the 3 data sets that I made are really different. The third data set, again, contains only one type of text, but it's very big. It's a large data set. Plus, it contains dialogue that is really heavy on things like emotion and personality. So instead of being, neutral facts, like the books in the Elder Scrolls data set, this one has a really varied cast of characters. So people interested in analyzing personality and linguistic style and emotions in narratives hopefully can use this data set. All right, I will now take questions in the workshop Zoom session, but if you watch this talk later or something comes up, feel free to send me a message and I'd be happy to respond. I can probably talk for hours about this, also about the technical details on how I reassembled all the game assets. You can find some information about that in the dataset on GitHub or the repository. But for the non-techies, don't be afraid. I made sure that all the data that I have is really easy to use because I put it in a CSV format. So you can just read it with Excel or your favorite programming language. I try to make it as usable as possible. So thanks very much, and I'll take some questions now.